it allows you to specify not just one single parameter over there or one single data set. It allows you to specify multiple data sets and do something like Spark, basically this distributed processing on multiple nodes. Hi, everyone. My name is Igor. I'm head of product at Coretex AI, and today I'm here with Vuk Majnolovic, one of our ML engineers. We're going to go through one of the workflows that we have. So specifically, Vuk is going to show us how to embed OpenLlama and large language models in Coretex workflows, and then run them as separate tasks. And specifically what we're going to do is we're going to do some sentiment analysis using Ollama models.
So we'll be using the sentiment 140 dataset from Kaggle. We can take a look at the code. So to begin with, here we have the system prompt, which we'll be using for the sentiment analysis to make the Llama 2 model basically behave like a sentiment analysis model. It will give us back 5 different categories: very positive, positive, neutral, negative, and very negative. So here we basically one-shot it by giving it an example on how it should respond, and it will be giving us responses just like this.
So just to backtrack a little bit, so OpenLlama model is basically a server that you download from the website, right? And then you get a server on your local machine. That's why over there it says Ollama server URL is localhost address on the port 11,434.
Yeah.
And then you have these roles, right? You have a role of the user and role of the assistant.
Exactly. Yeah. So right? User assistant is DI.
Right. Model. So this is basically you're pre-prompting it. You're giving it the instructions and simulating the conversation that you would like the model to continue. And exactly. This is like programming it to programming this generic LLM to actually perform sentiment analysis on whatever gets injected in this. It's a third, right? Third from the top prompt where it says text prompt prefix.
Yeah.
Okay. Cool. Right, and all of this is inside of a Python script, which is going to be uploaded to Coretex later on. So we're looking at it in a Visual Studio Code locally right now, and we're gonna move it up into Coretex and then make it read the data set with tweets, right?
Exactly. Yeah.
Cool.
So after that, we have some code for installing Ollama, because this will be run in a Docker container. So you have to do everything from scratch, install it. So check it first if it is installed and install it. Mm-hmm. Then you'll launch the server, then pull the model. Now we could choose any model that Ollama offers us. We can decide that here, the test.yaml file, which is basically the file containing all the parameters. So in this case, this will be the model. We'll choose Llama 2. Beyond that, yeah.
Sorry. So Ollama server, when you download it from the website and install it, it allows you to dynamically on the fly with one single binary specify the model that you want the Ollama server to pull as a Docker image, and then it feeds the prompt. Correct?
Yeah. So it basically runs the model on the server. Whichever one you choose, could be Llama 2, it could be Mistral. You can use some multimodal models.
Okay, and what you did there is you exposed, let's say, the ability for Coretex user to choose which model they want to use inside of the workflow with Ollama. You exposed it through a parameter, and that's this last segment where it says name of model and then description and value Llama 2, right?
Yes.
Can you show us how do you read the value of that parameter called model inside of the code?
Yeah, so this is read in process, it's passed forward to determine sentiments model. Yeah, it's ready right here. Beginning, we get basically a string. This will contain a string that gets passed over to pull model, so the Ollama knows which model to pull.
Sorry, but can you go back to line 155? So you are accessing the task run object dot parameters, and that's the list of all of the parameters that were defined in the YAML file, right?
Yes, exactly. So it's going to have all the parameters from data set to all these.
Cool. And there's this task run object, right? So you got it by invoking current task run. Okay, so your code has access to the current task run and all of the metadata around it, including the data set. I see. So task run dot dataset dot download. You can fetch the data set that way. That's good. Okay, cool. Yeah, I just wanted to see to pay attention to this small bit. So can we take a look? Can we like upload this thing now and set up the data set and move to Coretex?
Yeah, so we'll need to basically zip main.py requirements.txt, which, by the way, let me just show, is going to have all the packages which needs to be installed for the environment to function.
Okay.
So we do that, and the test.yaml, we compress those to an archive, and then let's go to Coretex. You can create a new one here. Use project. We can choose other because it doesn't really fit any of those.
So just one brief comment there. So we do have support for some tools with respect to data annotations and working with, let's say, DNA data or image data. So in those cases, you would choose some other type of projects like computer vision or bioinformatics or motion analytics and things like that. But since we don't have any structure over here, it's like a random CSV file, and we wrote the parser for it. That's why we're choosing other data types. That's the project types. That's very flexible, and you can just pump in any kind of data types there.
Yeah. So we're creating a new task. We choose from local folder. You can go back.
Is there any reason for creating the task first instead of workflow? Do we still need to do the task first?
No reason. I just do the task because it makes more sense in my head, chronologically.
Okay, yeah. Let's keep it like that. Let's do task first, and then let's create a workflow later and just put this task in it.
Yeah. So this is the task just created. Then we need to create
can we briefly go? Sorry, can we briefly go into the task just to see how it looks like?
Of course, it's similar to the VS Code.
It's the same code that we just saw on the local, right?
Exactly.
Cool. Okay, great. Good. So let's go to the next level. Like, let's create a workflow now.
So we create a flow on the one side. Let us choose the Ollama. So now we haven't uploaded a data set. Doesn't do that.
Yep.
So now I'll just save this workflow so we can go back to it.
Okay.
Let's go to data set. We can basically, I'm going to first show what it looks like here. So you're going to use a reduced data set. You're going to use all the 1.6 million tweets. It's a bit excessive. So just use 10.
It would have been a long demo, right?
Very long, yeah. So let's go to Coretex, and I already have them zipped up. Here are 2 samples. Choose these two samples with 10, or actually 11. This is a bit useful, but 11 CSVs or tweets in the CSV. So there's this.
Right. So right now that CSV file from your local machine just got uploaded to Coretex servers, and it's stored in our distributed storage, and it's going to be available for any node that's going to be running this. Correct?
Yeah.
Cool. And we can see it there. Okay, so data set is there, so we're going back to our workflow, no?
We're going to select the data set here. You can select now a machine, select local.
So, sorry, can we go back to the machine selection screen?
Yeah.
So we are selecting a machine that is hosted in our intranet. So it's right there in the office, and we have Coretex CLI with installed Coretex node and configured Coretex node. That's why it's visible in this list. And besides that, there's a bunch of cloud nodes that are kind of queues that you can send jobs to, and then those task runs are gonna spawn dynamically machines and scale up to satisfy the queue needs. But we're not gonna do that. We're running on a GPU-enabled local machine in the office there. Cool. Can you briefly please switch to the visual tab? Just to see how it looks like. So this is the workflow. Basically, you can see similar things, like there's a data set selected and it's fed as an input to one single task called Ollama, which is just another view of the advanced editor that we had a moment ago. Cool.
Yeah.
And we're ready to run, no?
Well, I haven't mentioned these two parameters. Basically, they allow you to choose which of the columns are the tweets. And if we go back, I'm just gonna go back here.
Yeah.
It's actually the fifth column, which has the tweets. Okay. So I added the fifth one. Alternatively, you could also add the input the name of the column, but this one doesn't have any, so you can just choose the index. And now we can run.
That's right. Let's run it. Okay, so it's already executing.
Yeah, so it launched the Ollama server successfully. It's down the model. It was downloaded and it's already processing the first tweet.
Right, so it's running inside of a Docker container right now, the whole process, right? So the whole experiment or the task run is being run inside of a Docker container. And that Docker container is running another process, an Ollama server inside of it, correct?
Yeah.
Cool. And we can see that it's actually it's sending the HTTP requests to the local host, right?
Yes. To the API chat.
Yeah. That's awesome. Right. And are these being moved to artifacts?
Yeah, as soon as it's done with one CSV, it uploads it as an artifact. So here we see everything. Nice.
Cool. Yeah, finally home is positive. Cool. And then you're right about that. It's neutral. I mean, taking into account this is not a model that is intended to do a thing like this. Usually, before this kind of agent-based world, we would have to train the network specifically to output one of these 5 categories of sentiment, right? And right now it's so generic and programmable on the fly, so to speak, that you can do things like these just by proper prompt engineering, which is quite impressive. Yeah, and at the end, I mean, this is really nice. We should kind of touch on the topic of why is this, like, why would somebody want to do this in Coretex? Like, what is the advantage of running this server inside of Coretex?
Well, it allows you to very easily launch a new experiment. You can easily change parameters or change the template on the fly as you need it.
And I guess also the parameter screen, we won't touch that today, but it allows you to specify not just one single parameter over there or one single data set. It allows you to specify multiple data sets and do something like Spark, basically this distributed processing on multiple nodes. So if you have a huge data set like this 1.6 million, you could segment your data sets into chunks of or whatever, and name any number, and spin up a bunch of machines and then parallelize the processing multiple nodes. So this is something that you could do. Another benefit, I believe, is that if you expose this instead of as a Coretex workflow, right? If you expose it as a Coretex endpoint, then you can send these sentences for analysis through an API, and then Cortex backend is going to forward them to the node. And effectively, what that means is you just bypassed all of the network settings, right? You hosted your model directly on Cortex, but on your private node. So Cortex was acting like a proxy. So that is another benefit and reason why somebody could choose to do this. We're going to leave that for another video. Thank you, Vuk. Thanks everyone for attention, and I'll see you next time.
Join our community today and learn how to execute your ideas with confidence.